Hello and welcome to this new lesson, in which we will talk about how does Arduino think. So, how does Arduino think? Arduino is programmed with ones and zeros, but hopefully that's not how we programmers have to write the code. Most Arduino programs are born through the use of C++ and C, two very common computer languages. Now, you may be wondering what a computer language even is. A computer language is a tool used to develop a set of instructions a computer is capable of understanding. In this case, the computer is an Arduino, and the set of instructions are quite simple, at least in this lesson. A look into the code. A very simple Arduino script usually starts out with an initialization of a variable to create an integer variable. Int is used, for example. This line of code creates an integer variable called led and assigns the value of 13. Now, we need to do something with this allocated variable. The next step is to create a function in which we will use the data stored in led to turn on a physical led. Void setup. Basically, this is create a function from which no value is returned, hence void. The function in the context of this Arduino program gives you the opportunity to configure any physical bin, input or output, and which bin to use. This line, as shown here, bin mod led output, this assigns the bin number to 13 and a digital setting of output to that bin. Bin mod lets Arduino know we're about to change the setting on a bin. Since led means 13 in the Arduino mind, we can simply put led. This also makes it much easier to change the bin in the future, as we can just change the variable to different integer. Bin 13 on the Arduino happens to be an led already installed. So, it's quite easy to try out this program without any extra hardware apart from the device itself. You can clearly see the led circled in the image below. Or, if you have hardware available, you can add your own led like so. There is still one part missing, the actual instruction. At the moment, the Arduino knows what the digital setting of bin 13 is, but hasn't any idea what to do with it. What we move into now is another function called loop. Commands in this function will be repeated in order until otherwise noted. For example, if we had the simple function of this lines like void loop led equals 1, led equals 2, led equals 3, our function will now loop through this instruction, settings led first to the integer 1, then 2, then 3. Once the program reaches the brackets notifier, it starts at the beginning again. For our program, we want to blink the light every second. To do this, we need 4 commands: an on notifier, a delay, an off notifier, and finally another delay, as shown here in the loop. The command digital write lets the Arduino know we are about to send a pre-configured bin some information changing its current state. In this case, we first define a bin as led, meaning 13, and then set its state to high, meaning full voltage on. Next, the delay command, which is in format of milliseconds and takes integers. In this case, we first define the bin as led, meaning 13, and then set its state to high, meaning full voltage on. Next, the delay command, which is in the format of milliseconds and takes integer. We then turn the led off and wait another second before repeating the loop. The final step is compiling. Now that we have written the code, the final step is to format it and send it off to the Arduino via USB. By format, I mean compile. Compiling basically turns your C++ and C into hexadecimal, which is one hop skip ahead of binary, ones and zeros. You can upload your code by going to File and then to Upload to I/O board, like this. Once the Arduino receives this special hexadecimal code, it begins to execute your program. You will see the light blink. If not, check your code and make sure there are no mistakes. Thanks for watching this lesson, and if you have any question, please ask it in the Q&A board. See you next lesson.